This has been done, right? This has been done, right? Okay, sample sizes and the sampling frequency. Another way, this is what we call the ARL. This is very important. It must be in the text. It must be in the text. 翻成中文就是它一定会考。Then, another way to evaluate the decision regarding sample sizes and sampling frequency is do the average round length. This is known as ARL of the control chart. Typically, we do have two types of ARL. ARLN and ARL. So when the process is in control, we expect, we wish ARL as large as we can, right? Average round length. Since once in a while there's a point product outside the control limit, then there's a signal. It's given. However, the process already in control, so we do not wish, we do not expect any signal has been given. If any signal has been issued, then we need to stop to check if the process is already out of control. This is really annoying. So we expect no out of control signal as long as the process is already in control. If it is out of control, then we expect it is as small as possible. That means the process out of control, that means we need to detect it as early as possible. We need to know the process is already out of control, so we need to stop the process to find what is the assignable causes, then provide action, try to remove those assignable causes, and bring the process back to the control. So in such a case, we need to detect as early as possible. That's why the ARL should be minimized. In control, ARL should be maximized. then, then. So the ARL is average number of points that must be plotted before a point indicates an auto control condition. So how long, on average, we expect a auto control plot has been identified. That is the ARL. Then if the process observation are uncorrelated, this is very important since in this chapter we're still talking about the SPC model. So the observation from the process, they are uncorrelated. So this is called the SPC model. Have we defined this before? Miss Ma? Hello? 牛 oh, I'm sorry. 你是姓牛嘛 right? 到底是牛还马？牛。Okay. Yeah, Miss Ma. Okay, Miss Cow, please explain this to me. What is this? Have we mentioned this before? Okay, what is this? What is this? Yang Ting? CT, critical to quality. Neil? Yes, this is constant, right? Epsilon T. Okay, cool. So, this is uncorrelated. If there is no correlation, it's assumed. So then for any Schuhart control chart, the ARL can be calculated like this. The ARL in, for example, equal to 1 over P. So what is the definition of the P? Where P is a probability any point exceeds the control limits. This equation can be used to evaluate the performance of the control chart. So then there's a question. If a 3 sigma control chart is used, so then what is the ARL in? Yang Ting? If 3 sigma is a control chart is used, what? P is a probability any point exceeds the probability. Okay, could you just calculate this number for me? Somebody use the cell phone or use a calculator. 要赶快去借计算机，快点！我告诉你，到时候考试的时候不可以传阅，每个人只能用自己的计算机。370。So what is the interpretation? 370. Mr. Christmas tree. How can you interpret it? 370. How can you interpret this number? 怎么解释啊？ What is the meaning?
算出来这个就是它的谬吗？就是它的谬。
No. Mr. Curry? Hello, Mr. Curry. Somebody? Jingyi. Now just say something. You won't be correct as for the first time. Don't worry. Speak out. Why not? What? 370. 370不是几率哦。It's not probability at all. Not. Then Mr. Doctor.
每370会有一个错误。
Very close. Very close. Thank you. Let me say something. Since the process already in, right? It's in control. This is the center line. This is the upper control limit. This is the lower control limit. For each point, it's a sample. It's a sample average, right? Then how many on average? Every 370 average. On every 370. Okay, sample. I would say that. Okay, sample mean. Sample average plotted, and there's a point will be extrapolate out of the control chart. 那我用中文讲一下，刚刚那个道奇先生讲得非常好。我的 process is already in control， 我的制程是正常的，正常的不代表说我跑出去有一点，就是代表什么制程有问题，对不对？因为我这边还是有0.0027的几率怎么样会超出上下管制界限，对不对？我不可能做出来100万个，全部100万个都是好的，不可能嘛 ，right？ 是不是？因为我们只有什么 3 sigma 的 quality level。Then under this, how long we going to observe one point plotted out of the control limit? That is the 370 sample average plotted. 来自己写在课本上。On average, approximately we're going to observe 370 sample average product. Then there's a point out of control. There's a point going to be plotted out of the control limit. Okay, this is the first one. Then, yeah, 370. So we call this is the AR. This is also called ARL, not zero. No, we call ARL null. Why? It is referred to the null hypothesis. Null hypothesis always stating the process is in control, right? Yeah. Patricia, are you following? Yes. So that is to say, okay, let me rephrase again. That is even if the process remains in control, an out of control signal will be generated every 370 samples. Get it? Okay. Okay, then the use of the average run length to describe the performance of control chart has been subjected to the criticism in recent years. Well, even though it is not fair, since the distribution is quite disruptive. So the reason for for this arise because the distribution run length for Shua chart is a geometric distribution. This is important. It follows geometric distribution. Then there's two concerns first one, standard deviation of the run length is very large. If the standard deviation is very large, then the then the number going to run really wide. Then second, geometric distribution very skewed. That means it could be the right skew. There's a tail extended to the right. And the mean of the distribution is not necessarily a typical value of the run length. It received much criticism. However, it still can be used. It still can be evaluated to give us an approximation how good or how reasonable that the control chart was constructed. Okay, then. So let me take an example. For example, ARL norm is equal to 370. That is the mean of the geometric distribution, no problem. Now we would like to calculate the standard deviation of the geometric distribution. So you take the square of 1 minus p over p. Then this is the standard deviation. This is this is also very big. So that is to say the standard deviation of the geometry in this case is approximately equal to the mean. So as a result, ARL norm, other inequalities for a Schuha chart, will likely very change. They're going to change up and down dramatically. This is the reason why. So furthermore, for the geometric distribution with the p, and the 10th and the 50th percentile of the distribution is the 38 and the 200 and the 256. Wow, this is so wide, so separated wide. So this means approximately 10% of the time in control run length will be less than or equal to 35, and 35 sample 50% it will be less than or equal to 256. So wow, this is totally wild. So that's the reason it received a lot of criticism. So this happens because of geometric distribution is quite skewed to the right. Skewed to the right, that means the distribution behave like this. Yes, skewed to the right. 偏态系数, right? That's elementary statistics. Okay, then also another important measure. Okay, equation 5.3 on page 187. It is also occasionally convenient to express the performance of the control chart in terms of average time to signal. So we do have an average run length, and after multiplied by h. So h are taken as a fixed interval of time that are h hours apart. How long you're going to take a sample. For example, if the ARL in is 370, then if the H is 1 hour, that means every 1 hour you take a sample. Then how long you're going to first observe the sample point that would be plotted out of the control limit. So 1 hour, 370 times 1 hour, so we're going to need 370 hours of the observation until the first point has been plotted out of the control limit. So the time, okay, how long? So that is called the average time to the signal. Then move to the false alarm, the bottom of the page 187. Okay, consider the hard bake process discussed earlier. Suppose that we are sampling every hour. That means every 1 hour we take one sample. And equation 5.3. Equation 5.3 on page 187 indicate we will have a false alarm. So what is the definition of the false alarm, gentlemen? False alarm. False alarm. Miss Zhao, what is a false alarm? Definition of false alarm. Mm. 你还敢讲，虽然是讲不对，没关系。Yeah, gentlemen. False alarm.
一种警报就是
假警报。So what is the definition of 假警报？
我们可以事先知道，因为它每370天就发生一次。
So
这个特别注意。
370，经过370个 sample 跑出来，这个就视为什么？假警报。That's great. So false alarm rate every 370, typically false alarm rate. That is equal type 1 error. And one error, also known as producer's risk, also known as false positive. Why we call the false positive? Why? Why we call the false positive, gentlemen? Why? 假阳性 like a COVID-19. Like COVID, you do the test kit, 快筛, right? The test kit. Finally, the test kit show you are COVID infected. Actually, you are not. Then there's a false positive. That is a false positive, right? And then, if the process still in control, however, there's a signal out of control limit. However, is the process doing okay? Yes. However, still a signal indicate the process is not okay. So it is false positive. Right? Okay, think about that. So, now consider how control performs in detecting shifts in the vent. Suppose we use using a sample size of n equal to 5, this sample size, that when process goes out of control, the mean shift to the 1.725 microns. And from the operating characteristic curve in the figure 5.9, where is that? In the bottom, 5.9, do you see that? right here. Okay, once the sample size equal to 5, changes was 1.759. Then from the operating characteristic curve, that is also known as OC curve. Just put a note on that. Oh, yes. Not it. How did I? 应该会是错的。Don't worry. 等一下变可惜。Interesting. ARL1 should be
一个0.35，一个0.65，
应该是okay.
大家都不一样。
低于30块钱带回去。
等一下，不是课本错就是 PowerPoint 错，我们上完我们就知道哪边错了。OK， then why the process is about 1.725, right? Then from the OC curve in figure 5.9, we find that process mean is equal to that the probability falling between the control limit. Probability at falling between the control limit n 等于5一点，大概是多少？我看一下，大概是多少？0.3多，是不是 ？Am I right? Am I right? So approximately 0.35, right? 0.35. So what is the probability extrapolate out of the control limit? The denominator should use the 0.335 since okay. So x falling between the control limit is approximately 0.35 between the limit. And out of the control should be 1 minus 0.35. So the denominator should be 0.65, right? So this is not correct. And then, yeah, this is correct. The textbook, the number in the textbook is correct. Then just forget about that. Then on average, what does it say? So auto control is about 1.5, 1 point something. Okay. Now this is total. Now this is not correct. Then ARL 1, right? 1.65. That is equal to what? 1 point something, right? 1.5 word. Okay, let me show you something. One base data auto control limit. Yeah. Yes. Okay. Hold on. Let me show you something. Let me go to the Google. Yes.
有中文版。是这个。坏掉了。这和谁贴？这个都。都没有完整，对吧？第三位。哪里有零标？
好，我知道。
我只是差对那个涂料。哎，这还有日光，还有这一本。
不要讲话，谢谢。
然后看个本。
还有其他吗？
那么
这一本书中还有另外一本书，是那个英文版中国的查证指数
等一下，我们可以的。等一下，我们可以的。
等一下是怎么说？我要吃饭。
我们贝塔应该是，对，没错，对，课本是对。啊？
真的有点。
这个是错的。Oh no， 等一下 ，hold on。Suppose we use the and when process no process is out of control. Out of control, it cannot be it cannot be no. It is one.
我是说以前面的
不是，它是 ARL1 就代表之前已经不在管制状态。因为在管制状态就看你几倍标准差结束，就没得讨论。没有，你今天2倍标准差，请问 ARL in 是多少？来，牛小姐。
2倍标准差。
2倍。2倍标准差。If we use a two standard deviation principle to construct a control chart.
0.05除以1除以
Yes. 0.05, right? This is about how many? 20, right? This is about 20. So fixed.
Okay.
It's fixed. So it is 1 over alpha. Alpha is corresponding how many standard deviation you construct. You construct the control chart. Then done. Then for this ARL1, that is to say process is out of control. Out of control. So that is equal to 1 minus beta. Then in this case, what is the beta? Could you tell me what is the beta? What the beta is, gentlemen? 学语鼓掌。你是学语鼓掌 ，right? What is the beta? 来看着。来，你告诉我，来 ，Mr. Yellow。看一下，你不要一直对我笑，你有毛病吗你？来，我们找今天最晚进来的女生，就你。什么？OK, so 贝塔是多少？你说贝塔是多少 ？Are you sure about that? 1 point. This is fine. No, this is the probability falling between the control limit. 0.35. Yes, correct. Right? Falling between the control chart, so we do not reject the null hypothesis, then we make the type 2 error. Am I right? Am I right? Since the mean has been shifted, we do not reject it, then we commit the type 2 error. So beta is 0.35. Then 1 minus beta is 0.65. Is 0.65. 来看一下，这个公式代表贝塔怎么来的？那个是 OC 曲线，有没有？代表什么意思？我们是不是犯了形而误差的错误？是不是？好，那请问点65是什么意思？是不是也是等于 P？ 仰停是不是等于 P？P 的定义是什么？仰停，来你再说一遍。P 的定义是什么？对呀，auto control 就是没有犯错啊，对不对？现在贝塔是犯错，什么时候犯错？点都什么在管制界限内，因为制程已经 auto control， 对吧？那1减掉贝塔代表什么意思啊？有没有犯错？没有犯错。我们如何在制程管制没有已经偏移了，制程不在管制状态下，我如何不犯错？就是点要画在哪里？超出管制界限。Alright, the process is already out of control. We need to detect it. So that point should be plotted out of control. That is P. So this is a 1 over. So this is not correct. So what is this number? 1.54. This is 1.54 on average. Average 1.54 number. Even though you need to run up. So the sample cannot be 1.5. It never can be. Can never be. So we typically run up. It's 2, right? Every 2 samples we can detect it. Yeah, so this is very early. Since the process already shifted, on average, there's only 2 samples, then we find it. And we stop the process and go back to check the sign of causes and provide the action to bring the process back to the control. All right, take a break.
这个意思呀。